Good morning, everybody. Hope you're all doing well. You see, the first thing is, with all the previous keynote speakers, they didn't have any slides. You can see that the professor is talking now, right? All right, let me figure out where the clicker here is. Is this the clicker that I should be using? Yes. Okay. I'm going to just quickly check it. All right, so what am I going to talk today? I'm going to talk about the balance between human and machine intelligence. There are three things I'm trying to achieve from this conversation. One, I want to show you how companies have set up their machine learning infrastructure. How did they go about? What's the economics behind it? Two, I'm going to show you how you need to be thinking about augmenting the human intelligence with machine intelligence. And three, don't blindly follow what the machine intelligence is telling you, and you really need to have the human intelligence to put some check and balance it. So that's all the message is, right? And I'm going to give you a few examples to explain the same 3 points. Some of the examples I'm going to discuss are conversations or engagements that the Carnegie Center and some of my research team has participated in it as well. Let me see if I can move this. Yes, okay. The use of machines and animals is nothing new. And we have seen hieroglyphs from 300 BC, which show how humans have used animals for farming. And we also know how Roman Empire has used horse-driven carriages. And last but not least, we are all guilty of using cars as mobility instruments or vehicles. In all these examples, if you think about them, it's been limited to or relegated to physical activities. Now the machines are becoming more sophisticated, that as you saw in the panel, they talked about how self-driving cars, which are capable of doing some intelligent tasks, are becoming very prevalent. And there's no point in talking about the self-driving cars because everybody knows about this. What's pretty cool about what I'm showing you there is this device called OpenPilot from Comma.ai. This is a development kit which costs less than $1,000 that you can install on many of the base model vehicles of Honda, Toyota, GM, some of the GM vehicles, and you can turn that car into a self-driving one. It's very spectacular. So you don't need to necessarily buy a huge Tesla, wait in line to get the Tesla. You can instantaneously turn it into one. Not into Tesla, but you know what I'm getting. Right? All right. So the part that's important here is, how did this company go about doing this? And what's the economic rationale behind this? This company somehow managed to get people to put up a video camera on their dashboards as they are driving. All the video was getting recorded and sent to a central location where they implemented deep learning, reinforcement learning algorithms. I'll talk about deep learning and reinforcement a little bit later as well. So these learning algorithms understood how you need to be responding without quite understanding what you need to do, right? So these are great technologies, and they have understood that, and the essence of those learning have been embedded in those development kits. Think about from the economic standpoint. This AI infrastructure required a lot of extensive data sets. And once you have the data set, it's easier to deploy in many devices as well, right? This is what we see with companies that are doing these sort of capabilities. Now, what I'm going to next show you is something called behavioral analytics. And I'm going to show this video. This is, pay attention to the center top corner where the Woba.ai is picking up what behavioral thing you're doing. When somebody's smoking, it's figuring out that person is smoking. This company is a startup that came out of Granite, not necessarily out of Granite. One of our alums is the founder of this product. And all these companies are creating such platforms. You saw Comma.ai create platforms. a platform, and here is Wobot.ai also creating these platforms. The Wobot.ai platform is very valuable for a single reason, right? So you can think about whether consumers or your employees are following some of the policies you're putting in place. In a restaurant, you want to have hairnets, and whether your employees are doing that. In schools, we hear about vaping becoming a big problem. Can we put these video cameras up and detect vaping as the students are engaged in these activities? Right? It's these sort of implementations that are actually becoming quite prevalent as well. This, what you're seeing in this picture here, is a research that we are doing. This implementation already happened, where a company has implemented AI-powered shelf monitoring system. These product manufacturers want the products to be at the eye level in the stores, and the labels of these products should be facing the consumers. So now with an image recognition software, they were able to perceive how good the company, how good these stores are in terms of keeping the product at the eye level, whether the labels are set up or not. So they have that software built in, and they came and gave us the data set. In the previous panel session, they were asking about ROI again. So one of the things that this company did is it simply didn't blindly implement these AI tools. It actually did some experimentation for it. What you see here is, think about the blue line corresponding to the stores where they implemented it, and the gray line corresponding to the stores where they did not implement it. These were the control groups. What you're seeing in the graph are the sales. On the left side, are the sales before the AI was deployed. And as you can see, the sales was very similar. And after the implementation, you can see how they are changing and evolving. Right? And so once, it's important that when you're deploying these, you make sure you can validate these outcomes before you deploy them as well, more broadly. In our case, we are seeing that when we talk to companies and others, these AI tools are very, very useful in situations where human decision-making is problematic. What do I mean by human decision-making is problematic? Humans tend to exhibit biases, inconsistencies. And for those situations, if you deploy AI correctly, boom, you're going to get some outcomes that are beneficial. Now, one of the examples I'm going to show you here is how inconsistent human decisions are. Suppose you came up for parole, and the timing at which you come up for parole determines the probability of your parole. Right? So judges, before they go home or before it's lunchtime, they tend to decline more of the parole cases. That's surprising, right? And this is probably because our minds are very tired. And this is from a PNAS article that somebody else has written. And this is the corresponding newspaper article that came about. And these would be some of the places where if you think carefully and then deploy AI, you are going to see benefits come out of it. Now, a large number of criminal justice system organizations, various courts, are using AI-based decision-making with respect to parole. So if you fed the past history and all of that, it spits out what the risk profile is, whether the risk profile is high or low. Unfortunately, not always are these predictions correct. And this is where I said you got to be careful about implementing it. ProPublica did an investigation with some of these software. And this is an example from literally their site. As you can see, the person on the right, an African-American female, who has had 4 prior juvenile offenses, or misdemeanors, not even offenses, being rated at a higher level, higher risk profile than on the person on the left, who's had 2 armed robberies and things like that. So when you're deploying AI, make sure you understand what causes these problems. Understand that AI can be biased too. And this sort of an issue has garnered a lot of attention in our community. And we've developed many fair machine learning algorithms. Some of those algorithms that are from the community have been deployed by IBM on Watson, called AI Fairness 360 measure. So they took some of the prior work, implemented them as a part of the AI Fairness 360. Well, not all the algorithms are completely satisfying the regulatory requirements. There is discussion again in the research community about whether some of these algorithms are violating the Civil Rights Act of 1964. In my research group, we have worked on some of these problems as well, and we have come up with a concept called best response fair, which not only takes the fairness at the outcome level, but also thinks about fairness at the effort level. So if I'm changing the metrics for the two subpopulations differently, or in some regards, evaluating these subpopulations differently, how do I make sure that it is best response fair, in the sense the subpopulation's reaction is also fair? If you're interested, we can talk offline. This is not probably the platform for me to get into the details here. What I'm pointing out here is there are many such technologies and concepts that are becoming relevant as companies are deploying AI a lot more. Another one that's becoming very important is something called explainable AI. And the idea here is, think about on the left side, you have all these great training data sets. We had panelists talk about that again. I have lots of images, and I'm training my machine learning algorithm to identify whether there is cancer or not. And just like before, think about an essence that comes out of this algorithm, whatever deep learning algorithm that you might use. And you've created the algorithm in execution. Suppose a new picture comes in, it identifies, hey, there is cancer or not. And it gives you the confidence interval and all of that stuff. Do you think the physician is going to simply take that information and say, okay, now I'm going to start performing surgery on you? Right? That's not going to work. And the physician is going to ask, why? See, when we talk to many companies, there is an engineering company which we work with, which has large amount of data sets. And they're trying to figure out which feature to fix in this engineering problem. And one of my colleagues, Ilyas Bill, and I will be talking about, not related to this, but he's been co-authoring with me on that piece. How do you use these data sets to be used in an explainable fashion? This issue about explainability has become quite prevalent because there is a trade-off between explainability and predictability. What you see in the right bottom corner there corresponds to decision trees, where we can find out, we can explain the predictions pretty much, explain the understanding behind it. But that's terrible from a predictability standpoint. Remember the deep learning and the reinforcement learning that I talked to you about for the self-driving cars? It's on the left top corner. The predictability is great, but we have zero clue about what's going on. Right? And these are black boxes, and many of these decisions are being made based on these. So there is a significant effort towards developing these explainable AIs. And as I said, we've been working with an engineering company looking at causal inference-based models from the data sets and creating explainable solutions as well. What I'm pointing out in the slide is this is all great, and you want to think about explainability and all of that. And you want to have the humans in conjunction with these AI. That's where we see the future is. To reiterate this point, I'm going to show you a study from Harvard where they did give lymph node slides and fed them to a machine learning AI tool. And they also gave them to humans. And this is how the AI tool performed, 92% accurate. Yeah, for the humans, right? And so 96% accuracy for the humans. What was surprising was when you put both of them together, it was 99.5% accuracy that they could obtain. So what's important is, yes, there are these cool technologies that you can deploy. Figure out how you can put them in conjunction with people who are doing it, people who know what they're doing, and scale it up very quickly. That's the key to their strength. When we interact with companies as a part of the Carnegie Center, we see companies in various stages. And as our dean mentioned earlier, there are companies that are getting their feet wet. There are companies which are much more sophisticated. I picked up this picture from Gartner for a different reason. They presented it for a different reason. I'm using it for a different reason. But it explains something very important. When you look at the Harvard study that I talked to you about, the AI along with the humans, where the major portion of the decision can be done in conjunction with the humans, you can think of it as being in the lowest bottom part of the spectrum. Very few companies are in that space, right? And the explainable AI I talked to you about, the fairness and things like that, just so that we have an understanding of what the decisions are, that's somewhat slightly up, right? You can see why did it happen, what will happen, and things like that. We realize that many companies are in this space here as well. Based on our interactions with both government entities as well as companies, we realize that they are data rich, but information poor. They may have huge amount of data sets, they have little idea about how to put them together, oftentimes, right? And sometimes these companies are also struggling to get the infrastructure up. At Purdue, we have IDSI, Integrative Data Science Initiative, which is broadly the effort, again, our dean talked about. There is a lot of work that's going on, and we are part of, our center is part of that initiative as well. And we try to solve many of these problems. But what I want to give you a few points to think about is, how do you think about your company? Think about from your perspective. From your company's standpoint, how do I think about these implementations? How do I set up this infrastructure? How do I scale? How do I put the humans in conjunction with the AI? Hopefully, I've moved the needle a little bit in that regard. And with that, I want to conclude. And thank you for the opportunity. Feel free to email me.